Good morning, everyone. And those who haven't arrived yet who will be filtering in, good morning to you all. Today is Friday, April 11. This is the final day of PFAS Forum, and we thank Gene Jones and his team for once again providing an excellent conference for this particular topic. Today is session 4, called Emerging Remediation Tools and Techniques for PFAS Detection, Tracking, and Sequestration. My name is Richard Oliver with Energy Transaction Advisors, and I am the moderator. We have an excellent group of panelists up here talking about some very timely topics. I'm sure you'll find them of interest. The format will be the speakers will talk for roughly 25 minutes, allowing 5 minutes for questions, unless they choose to take the entire time. And in any event, there'll be a sharp cutoff every half hour to allow everybody to speak. The first speakers, there are two actually on topic, Nicholas Nigro with Pace Analytical Services and Vitale with Montrose Environmental Group. And Rick, if I may, I'll please, the podium is yours.
Good morning, everyone. Thank you for showing up at 8 o'clock. So for the ongoing discussions about the nasty four-letter word PFAS, one of the things that has become more and more important, and I've heard a number of speakers talk about this idea of what is the definition, it constantly changes. And I sent an email to a bunch of my EPA colleagues within the last few days and asked the question, you guys have a definition yet? And the answer is no, we don't. So it puts a lot of things in bad situations in terms of regulatory actions, particularly more on the consumer product side of things than on the environmental side of things. On the consumer product side of things, this concept of total organic fluorine has become extremely relevant. We can't measure every single one of those over 7 million by some definitions. So we need something that will give us, for those of you of age that remember the total petroleum hydrocarbons 418.1, there you go. It's a total number. We don't know what it is, but it's a total number. So the acronym TOF, not time of flight, total organic fluorine, has become relevant. So our Nick and I's topic this morning is total organic fluorine. It's been dubbed the Proxy method for total PFAS. And why is that important? So first and foremost, there's no such thing as a single measurement that will give us total organic fluorine. No such thing. It will be a series of measurements, and most of which we don't have at the moment. What we do have is a very, very good measurement for total fluorine, okay? So if your total fluorine number is good, you're done. Unfortunately, in a good chunk of the times, it's not. So then we have complications and challenges. So the term is used, the total organic fluorine term is used and become de facto operational definition, but it definitely needs clarity. So I'm going to talk about key concepts, and my colleague Nick is going to talk about targeted methods, non-targeted methods, a cosmetics case study, notice I said consumer products, and some takeaways. So what does the total imply in total organic fluorine? A very complicated slide, but a very, very good table to refer to. This is the ITRC PFAS family tree. And it divides the PFAS groups into perfluoro, polyfluoro, and polymers. Okay, those are the main three categories of PFAS that we're we're really concerned about. The perfluoros are the carboxylic acids, the sulfonic acids, our buddies PFOA and PFAS, okay? The perfluoros are typically the ones that are really regulated quite a bit, although the polyfluoros are getting there. The polyfluoros are all precursors. They're the fluorinated ethers and the telomere alcohol, fluorinated telomere alcohol groups. And then we have the polymers. The polymers are PTFE, also known as Teflon, and the fluorinated acrylates, methacrylates, Scotch guards, etc. So this is an important concept because as it relates to TOF, total organic fluorine, okay, we can get some of these with some techniques and others with other techniques. But again, we still don't have techniques to get them all, and we definitely do not have one measurement technique to get all of them. Oh, I did that already. Okay, definitions. This is people have probably seen most of this, but as a practical matter, let's talk about some of the definitions. During 2011, Buck et al. Basically described a carbon that is saturated with that is bonded with 3 fluorines, so a CF3 moiety, okay? And there was about 270 of them, and they specifically left out fluoropolymers. It's like, who cares about a piece of plastic? Basically, I think was the concept. PFAS that were not available, and I think fluoropolymers fell into that category. In 2018, OECD came up with 3 carbon atoms that were replaced with fluorine, okay, and they came up with 4,800 of them, okay? So we boosted by a factor of 20, okay? Then in 21, we go to over 7 million. This definition actually has some legs. It's a CF2 or CF3 moiety, okay? Which means everything down to a single carbon, okay? Trifluoromethane, for example, would be considered a PFAS because it is a CF3 moiety, okay? And all of the fluoropolymers, CF1 million, okay, would be considered a fluoropolymer. The states started putting their 2 cents in. Many of the states currently have a definition of organic fluorine chemicals containing at least 1 fully fluorinated carbon atom, fully fluorinated. So what does that mean? Well, one state I was recently dealing with on a legal matter defined it as a single fluorine bonded to a single carbon, okay? And they went one step further to say it doesn't even need to be an alkyl, okay? It can be an aryl, it can be an aromatic. A single fluorine bonded to an aromatic, okay? So there remains to be a lot of confusion, but back to California for a minute. So California, besides their definition, are regulating PFAS only if it is intentionally added. Now, legal folks have interesting ways of describing intentionally added PFAS, okay? If we're fluorinating something and our product has a couple of fluorines on it, is that intentionally added PFAS? Or if we have 4 things and we're adding a 5th, which is a PFAS, is that an intentionally added PFAS? I think it's the latter. I think if you're formulating something and it has fluorine, it's not the intention of intentionally added PFAS. Anyway, California also has a regulation which a lot of people point to as it relates to consumer products of a value of 100 ppm, total organic fluorine. If it exceeds that, no, you're not allowed into the state. The Europeans, by the way, about a year and a half ago, proposed the value to be 50 for total organic fluorine. Okay, both the Europeans and California, by the way, don't have a method for total organic fluorine, so this is pretty important. EPA, as I said, they don't have a definition yet, and they're going to go on a case-by-case basis. So depending on what the situation is, they're going to punt. So what does organic fluorine imply? Oh, that's cool. One too many. So this is a pretty interesting graphic because it describes the breakdowns of total fluorine, and then inside is organic and inorganic fluoride. So the universe in red on the outside pink coating of our M&M is total fluorine, okay? And we have a way of capturing this. Very cool technology, and it's called CEAC, combustion ion chromatography. It will give us total fluorine number, pretty accurately, pretty precisely, in fact. So on consumer products, this is one of the techniques that's used to at least give us a gauge for, is there any fluorine in it? Inside that is the inorganic fluoride, and I'll talk about that a little bit next, but the blue one is non-extractable PFAS. That's all the different types of PFAS that are not extractable by our current methods of extraction. So methanol, for example, does not extract fluoropolymers, okay? A little bit, but nothing that one could say is quantitative. The white egg is extractable organic fluorine, and that is methanol extractable, and adsorbable organic fluorine. That's method 1621, running your aqueous sample over carbon, then burning the carbon. Okay, that's adsorbable organic fluorine. Finally, the little green egg is the individual speciated PFAS that we get by method 1633. Truth be known, if the world of PFAS was the entire egg, that green egg by 1633 would be so small you wouldn't be able to see it. 40 plus compounds in the universe of 7 million. That's what we have standards, that's what we have a speciated method for. I want to talk about inorganic fluoride because this is important also. Just as we have challenges on the extractable side where we can't extract the polymers, we don't have a really reliable method that will get both the insoluble salts and the soluble salts, okay? And it is problematic. There's some major assumptions being made by some of the commercial laboratories that if they do a water extraction and there's nothing there, there is no inorganic fluoride. And that's just not true, as you can see. Fluoride is an anion. We have a variety of insoluble salts, and we've got a variety of soluble salts. The key issue when we're analyzing it is to dissociate everything, okay, into a soluble form. If we have wastewater, it's reasonable to consider that anything in the wastewater that is soluble, that is fluoride, is inorganic. On the solid matrix side, some of the problems that we have seen is that, again, laboratories do a water extraction and they get nothing, and the assumption is that there is no inorganic fluoride. Unfortunately, water extractions do not get any of the inorganic salts, okay? So the assumption of not detected could be problematic because what's basically happening is they're doing a subtraction. And they're claiming that organic fluorine is what's left over after the total minus the inorganic. So the procedure for the inorganic fluoride needs to really be looked at hard in terms of, is that subtraction a valid thing to do? Quickly, total fluorine. So to review again, the fluoropolymers, we can't extract those with methanol, plain and simple. The non-targeted methods, we can get total fluorine, okay? The non-targeted, we can get some of the extractable organic that is not fluoropolymers. Volatiles, we can it requires GCMS analysis. Again, if we're talking about over 7 million, we now have volatile PFAS that we have to consider, short chain and ultra short chain PFAS, okay? And both of those require instrumentation and analytical standards to be able to develop those. On the non-target side, we can combust total fluorine, and we can potentially extract some of the extractable organic fluorine for some of the smaller chain volatile PFAS. Similarly with the ultra-short chain, okay? We have to develop methods and standards to be able to do those. We can do total fluorine. Total fluorine will get some, but we'll lose some. Just like you open a VOA vial and some of it goes away, you have some left, okay? So to do total fluorine, we will get some of the ultra-short chains, but we will lose a bunch too. Similarly on the extractable, we'll get some, but we'll lose a bunch, okay? So compounds without analytical standards, well, evolving, but slowly. At what point are we going to have 7 million reference standards plus? Okay, so we need to prioritize what is it we're measuring, and what does this TOF really mean when we're looking for it. And with that, I'm going to pass it to my colleague, Nick, who will continue.
All those big boxes. Perfect. Thank you, sir. Thank you. All right, so I'm going to talk now a little bit about some of the methods that we use to quantitate what is colloquially known as total organic fluorine. But going back to that very first point that Rock said, there is no single method for total organic fluorine. Our sales folks and our project managers from the laboratories, get requests all the time. We've got 10 samples that we want, 1633 and top assay and TOF. And we have to go through and discuss, all of these key concepts, which is in part why, Rock and I put our heads together to put this presentation together, to walk through all of those. So first I'm going to start with the targeted methods, even though as Rock indicated, and I think there's the targeted methods just gets you the tip of the iceberg. The rest of the organofluorine is below the waterline there. And this graphic, this image just puts that in additional context in terms of the number of compounds that can make up total organic fluorine, what the targeted methods can detect versus all the rest. So just a quick snapshot of the toolbox for the targeted methods. I'm not going to go through these in any detail, but these are the primary tools we rely on. For drinking water, we've got the 500 series methods. For non-drinking water, there's the EPA method 1633A, 537 modified, and 8327. And then ASTM has a couple of methods, newer methods, D8421 and D8535. And then we're also working on developing some additional methods that I'm going to talk about in a slide coming up. So we'll focus most of the time here on the non-targeted methods. And as Rock indicated, the first one, what I would call the best one in terms of quantitating what it states, total fluorine by combustion IC. What does it tell you? It gives you the concentration of a sample. Both the organically bound and the inorganically bound fluorine will be combusted into HF gas, and then that's quantitated by the IC. What it won't tell you, however, is what the concentration of PFAS is, and that's where that statement in terms of it being a proxy method for PFAS is often used. And it's also not going to give you the quantity of TOF. Now, it can be paired with an inorganic method, much like we use for 300.0 or 9056 to quantitate the inorganic fluoride, but then it's going to be that subtraction. And then the critical point is, if the total fluorine number is a good number, but the inorganic fluoride number is biased low, because of the limitations of the extraction method for an inorganic fluoride, then your TOF by calculation is also going to be biased high. The second tool, non-targeted tool, now this one is a published method. This is absorbable organic fluorine, and it was published in 2024 as EPA method 1621. The definition that they place in the method itself really gives you a good understanding of what it does quantitate, and there are some key points to that. It gives you all of the PFAS compounds and non-PFAS compounds, because there are organic fluorine pesticides and pharmaceuticals that can be absorbed onto carbon, which is another key point, because some of the short chains and certainly the ultra short chains won't absorb onto the carbon, and therefore they won't contribute to the quantitation. Again, absorbable organic fluorine, it's not going to give you a concentration of PFAS, but it is a definitive method with known precision and accuracy. So it's a good quantitation for those absorbable organic fluorine. Next is the extractable organic fluorine, EOF. There isn't a published method for EOF yet. The good news is EPA is actually working on a method to publish a method for extractable organic fluorine. They want to use it and publish it as a drinking water method for the drinking water division so that even in a drinking water where we're only looking primarily focused on those 6 compounds that have MCLs, you can get an understanding of the total PFAS via an extractable organic fluorine. But again, it's limited to only those PFAS compounds that will extract in methanol. A top assay is another non-targeted method that's used to understand the iceberg below the waterline in terms of total PFAS. And the good news with top assay, right now, all of the labs that are doing it, like PACE, had to basically develop our own method based upon the PhD, thesis back from 2012. But EPA is in the process, fairly close to publishing a method that will then put everybody on the same page. And then there's non-targeted analysis, NTA, using high-res mass spec. The challenge with that is it certainly gives you a peek underneath the waterline in terms of identifying compounds, but it doesn't provide much information in terms of quantitating it. So I mentioned that ASTM has got a couple of key things going on as it relates to this. And Rock alluded to consumer products. There's obviously a lot of movement and activity in that space. The very first bullet, the F3700-25, if you are dealing with consumer product related testing needs, that's a good standard guide to walk you through all of these issues as it relates specifically to consumer industrial products. And then that same group on consumer products, that same committee, we're actually in the process of developing 2 methods. One is the targeted method. That's the first, the WK88581. Those are work items that will become a published method. And that's an extractable, fairly similar to 1633 or D8535, but it's going to be validated for a consumer product. The second one, and that's the one that Rock and I and a team are working on as we speak, standard test method for total organic fluorine. Now, we've said it a couple of times, total organic fluorine, there isn't a method for that. If you think of total as all organic fluorine. But what we're evaluating is there's several solvents that are much more aggressive in terms of being able to actually extract the side chain fluoropolymers and maybe even some of the fluoropolymers themselves. So we're developing that method. We're looking at THF, for example, as an organic solvent, DBA as an organic solvent, ethylene cellusolve, 3 very aggressive solvents that are going to get us closer to total. There'll still be some limitations in that, but that work is ongoing. Doing pretty good on time, I think that's. All right, so quick case study here. And I use this one because it's a peer-reviewed, published journal, which I give the citation down there. I encourage you to get that and read it in full because it goes through all of the details. But this just kind of highlights some of the things that we've discussed in terms of the different approaches and what it's going to tell you in terms of a sample. So the first one is the total fluorine by combustion IC. And you can see that the concentration in relative terms is very high. The second one, in this research, they actually did an extractable organic fluorine, and then they combusted it by CIC and quantitated that. you are, capturing a good amount of the organofluorine, and there it would be just the organofluorine. And then lastly, in terms of the targeted test, and you can see, at least in this one example, how small the sum of the targeted PFAS is relative to the total fluorine or the extractable organofluorine. The big question mark, however, that would remain is what is that delta between where extractable organic fluorine ends and total fluorine? Is that an inorganic fluoride? Is that non-extractable PFAS? It's unknown. Just kind of shows the broader depth of this study. And as you can see, there was about 25 different cosmetic products that were part of this study. Some of them have very, very high total fluorine, but no extractable or no targeted, versus the ones, the foundations for ladies who use foundation. These had, at least these three had some pretty high hits, including the extractable organic fluorine and the targeted PFAS. All right, so some right on the money here. Key takeaways. The only way to get close to total organic fluorine is by subtraction. Total fluorine minus the inorganic fluoride, understanding those caveats. There are ways to eliminate the inorganic fluoride in the extraction. That's via the extractable methods. Many of those categories, subcategories of total fluorine are very challenging to quantitate. And the mass balance, because that's, in addition to quantifying, total organic fluorine, for example, in consumer products, all of these methods are also very heavily relied upon when you're trying to close the mass balance of, let's say, when you're doing treatment and destruction. Can you ever close the mass balance completely? Probably not. But with some careful discussions, with the lab and utilizing several of these tools, you can get pretty close. So with that, and 12 seconds left, I don't know if we have times for...
Yes, I think we have time for probably 2 questions, please.
You're going to tell all the women
There's one over there.
names of those foundations?
Right, there we go.
I meant to find a expert on the methods. So last December, EPA released their proposed human health ambient water quality criteria, with the PFOA being 0.0009 nanogram per liter. The experts say there's no way you can measure that, detect that. I just want to hear from you guys, is there a way to do that, and how do we set up that criteria if there's no way of measuring it?
Sure. So some colleagues from a variety of different commercial laboratories, my colleagues Nick's laboratories included, we all kind of chuckle when we see these numbers, the AWQC as well as the HAL numbers, health advisory limits. And there is, theoretically, with a clean room and doing, if we talk about aqueous media for a minute, if we extract something like 17 gallons, which will take about 12 and a half hours to extract, we blow the extracts down to a ridiculously small amount. We inject as much as we can and do the Hail Mary that the reagents in the background aren't confounding everything. It is theoretically possible, but in a practical sense, it's the background itself, the ambient background, the air in the laboratory, the reagents that are used, the surfaces of the labware that are used. It brings to mind, is it real or is it Memorex, if you get detections that low? And that is a fundamental problem if we can't have confidence in the trace level detections.
And the one thing I'll add to that is, the good news is I think there is a growing understanding with even the state agencies and the federal agencies that, while they might be publishing these screening levels that are, so exceptionally low, that the commercial laboratory, pool detection limits can't meet them. And so they're, allowing the laboratory method detection limit to become the screening level. But I think there's just growing, awareness of that shortcoming, that you can't get that low.
Okay, thank you very much. Our next speaker is Dr. Paul